In today's video, here is a nice problem regarding arithmetic and number theory. Here is the following setup. Find all A, B, and C as a natural number. Satisfy this following statement. So the first condition, we have 1 is inferior or equal to A is inferior or equal to B, B is inferior or equal to C. So the equation is satisfied this condition. We have the inverse of A plus the inverse of B plus the inverse of C equals 7 over 8. Okay. In fact, this is very nice and straightforward problem. In order to find the special values of A, B, and C, we are going to guess. Okay. So at certain points, we are going to figure out which the value can take A or B or C, either one, in order to make a nice balance for this equation. Okay. So let's take a look at this equation to see how to deal with this one. Okay. So first of all, I'm going to start with by the way of contradiction. So by the way of contradiction, suppose A is super equal to 4. Okay. If you have A super equal to 4, so I get here 1 over C is inferior equal to 1 over B is inferior equal to 1 over A, which is inferior equal to 1 over 4. Because if you take the inverse of this one, the inequality will be flipped in the other direction. Okay. So the next thing up, I'm going to sum these numbers. So I get 1 over C plus 1 over B plus 1 over A. Okay. So the sum of this one, we already have 7 over 8. Okay. So if I'm going to sum of them here, I get 1 over 4 plus 1 over 4 plus 1 over 4. Always, since 1 over A is bigger than the others, so which means the maximum then can take 1 over A is 1 over 4, which means all other terms must be inferior to these two terms, 1 over 4. Okay, so this one is giving us 3 over 4. But this one is not true, it's impossible. Why? Because 7 over 8 is bigger than 3 over 4. Okay, so which means A cannot be superior equal to 4. This one is telling us A must be inferior equal to 3. This is one side. On the other side, so based on this condition, we know 1 is superior equal to, we know 1 is inferior equal to A, and also A is inferior equal to 3, which means A is going to take this set 1, 2, and 3. Okay, let's prove number 1 it will be rolled out of this possibility. Why? Because if I'm going to replace A with number 1, I get here 1 over B plus 1 over C equals 7 over 8 minus number 1. Simply replace A with number 1, then taking number 1 to the right, I get 7 over 8 minus number 1. This one, but this one is strictly inferior than 0. It's negative, which is impossible. Which means A is living in this set 2 and 3. Excluded number 1. Okay, since A is taking two potential values, number 2 and number 3, let's go through each one. Okay, so case number 1, if A equals 2, so I'm going to replace A with its value here. I get 1 over B plus 1 over C equals 7 over 8 minus 1 over 2. So I replace A with number 2 and take the value of 1 over A to the right, I get to this fraction. So by calculating this fraction, let's make 8 as a common factor here. So I get, let's multiply this one by number 4, I get 4 here, 7 minus 4, which is 3. I get 3 over 8. Okay, I'm working on this value, but we need B and C. How to deal with B and C? So I'm almost doing the same job that I have before. So if B is superior to 6, okay, let's guess. I'm going to guess B is, if B is superior to 6, what is going to happen? Take this inverse of this one. This one is telling us 1 over B plus 1 over C is inferior to 1 over 6 plus 1 over 6, which equals 2 over 6, which equals 1 over 3. Okay, we know this sum equals 3 over 8. Okay, but this one is not true as well, because this one 3 over 8 is giving us 0.27, this one is giving us 0.23, which is impossible this one to be inferior to this one. Also it's impossible. What this mean? That mean b must be inferior to 5, not this one. Okay, this one is not true, this one is true. On the other hand, we know b is superior to a. We already know a equals 2, which means b is going to be superior to 2, which means b, we know a is inferior to b based on the given information that we have before. This one b is inferior to 5. So already you know a equals 2. So this one is telling us b is going to be in this set 2, 3, 4 and 5. Okay, so let's do this one on this way. So for if b equals 2, if b equals 2, so this one is telling us 1 over c equals 3 over 8 minus 1 over 2. Okay, so I'm simply replacing b with number 2 here, then take this value to the right and calculate this fraction. So let's put this one is giving us 8 as a common denominator. I get here 3 minus 4, which is minus 1 over 8, which is strictly inferior than 0. Okay, this one is impossible because it's negative. Okay, so let's check the other case. If b equals 3, so I'm going to do the same job here. I get 1 over c equals 3 over 8 minus 1 over 3. So I get 8. 9 minus 8, which is 1. Let's take the inverse of this one. So this one is giving us c equals 24. Okay, I will have a first solution here. I get a equals 2 with b equals 3 with c equals 24. Let's look for other solutions. If b equals 4, I get 1 over c here equals 3 over 8 minus 1 over 4. Okay, so I get 1 over 8. Okay, so by taking the reciprocal of this one, I get c equals 8. Okay, so I have another solution here. I get a equals 2 with b equals 4 with c equals 8. Okay, let's check the final solution for this case. If b equals 5, I get here 1 over c equals 3 over 8 minus 1 over 5. 7 over 40, by taking the reciprocal of this one, I get c equals 40 over 7, which is not integer. This one is not integer, which means we have no solution for this one. Now we have finished all these possibilities. We extract 2 solutions from this one, which this one here. So now let's move on to the next case. Let's move on to the next case when we have a equals 3. Okay, I'm going to plug this number of a here to see what's new expression. I get 1 over b plus 1 over c equals 7 over 8 minus 1 over 3. So after replacing a with number 3, I took it to the other side. I get to this fraction here. So calculating this fraction, I'm putting 24 as a common denominator here. Multiplying this one by this one is given as 21. This one is given as 8. 21 minus 8, which is 13. Okay, now let's work out to find b. Okay, if b is superior to 4, okay, let's take the sum of this inverse here. I get 1 over b plus 1 over c, which is inferior to 1 over 4 plus 1 over 4, which equals half. Okay, so for this sum which we found here, we get 13 over 24. Okay, let's use a smooth trick to compare this one and this one. So we know 13 is the same as 12 plus number 1. 12 over 24, which is half, plus 1 over 24. This one we have a half here, we have a half here. So this one, which means this one, it's impossible to be smaller than this one. Okay, this is impossible, which means b must be inferior to 3. All right, so on the other side we already know a is inferior to b, but a equals 3. Okay, we know a is inferior to b, and b we found it is inferior to 3, but we found the value of a which equals 3. This one we have b between number 3 and 3, which means b must be equals 3. Okay, if b equals 3, let's replace it here in this equation here. So I get 1 over b plus 1 over c, which equals 1 over 3 plus 1 over c, which equals 13 over 24. Let's take this third to the right. I get 1 over c equals 13 over 24 minus 1 over 3. So I'm going to put 24 as a common denominator here. This one was multiplied by number 1, 13. This one must be multiplied by number 8. Okay, so 13 minus 8, it's clearly 5, equals 5. 5 over 24. If I'm going to take the inverse of that number right here, so I get c equals 24 over 5. But this one is not integer, which means it's impossible to have a solution for this case. A equals 3, we have no solutions. So the only solution that we found, which is this one, these two solutions. Okay, thank you for watching. I will see you next video. Bye.